AT1031, Chapter 2, E. Crankshaft and bearings, flywheel, intake and exhaust manifold. Crankshaft. The crankshaft acts to convert the reciprocating motion of the pistons into rotary motion. It receives great force and revolve at high speed. The crankshaft is made of forged steel alloy to gain enough strength, rigidity, and durability against wear. It is also statically and dynamically balanced to rotate smoothly. The crank pin and the crank journal are attached through a hardening process. This helps to endure and be durable against wear. The balance weight is installed to balance the crankshaft rotation. The crank pin and the crank journal has oil hole. The oil travels from the cylinder block, enters into the oil hole of the journal, and goes through the crank pin. What is crankshaft offset? Offsetting the crankshaft center and the cylinder bore center raises engine efficiency. The piston can efficiently transfer the maximum amount of combustion pressure to the crankshaft, lowering the amount of force in the thrust direction of the piston, reduces friction loss. Examples of this are the following: 1 NZFE and 2 NZFE engines. The crankshaft offset of this engines are 12 mm or 0.472 inch, while the 1 SZFE and 2 SZFE engines has a crankshaft offset of 8 mm or 0.315 inch. Bearing cap orientation. The following are inscribed on the crankshaft bearing cap. The numbers of the journal installation position. Installation orientation. Crank pins and crankshaft journals receive a large load from combustion gas pressure from the pistons. They rotate at very high speed. For this reason, crankshaft bearings are used between them and are lubricated by oil. There should be appropriate oil film on the surface of the bearing. This allows the bearing to absorb heavy load and shock. The oil film prevents seizing and reduces output loss due to friction. Parts of crankshaft bearing. Oil hole and oil groove. There is an oil hole and oil groove in the upper half bearing. It supplies oil to the bearing and main journal. Locking lip. It keeps the bearing from rotating. Thrust washer. The thrust washer absorbs the force applied to the crankshaft in axial direction. It has oil groove on its surface that touches the crankshaft. There is a tab on the bottom side thrust washer to prevent it from turning. There are some engines that do not have the bottom side thrust washer. Insert type bearing. Insert type of bearings have outstanding wear resistance and seizure-prevented performance. The inner side of the bearings consist of steel shell and linings that are made of other metals. The linings of the bearing have direct contact to the crank pin or the journal. Insert type bearings are made of several types of metals. Generally, these are made of white metal, Kelmet metal, or aluminum. Types of insert bearing. There are 3 types of insert bearing. A. White metal. B. Kelmet metal. C. Aluminum metal. White metal. White metal is a steel shell coated with tin, lead, antimony, zinc and other coatings. This is often used in relatively low-load engines. Kelmet metal. Kelmet metal is a steel shell coated with copper and lead alloy. It is used in high-speed and high-load engines. It has greater strength and greater fatigue resistance than white metal. Aluminum metal. Aluminum lining is a steel shell having aluminum and tin alloy added on it. It has better wear resistance and heat radiation than white metal or Kelmet metal. It is commonly used in gasoline engines. Other engine parts. Oil pan. This is the reservoir of oil in the underside of the engine. The oil pan is bolted to the crankcase via a packing seal, or gasket. And oil pan is made of stamped steel, or aluminum alloy. Oil pan is provided with separators to maintain enough oil in the bottom even when the vehicle is slanted, as when moving uphill or downhill. Separators prevents the engine oil to slosh forward when the vehicle stops suddenly. This allows the continuous feeding of oil pump at all times. Flywheel. The flywheel is a heavy cast iron wheel. It is bolted to the rear end of the crankshaft in manual transmission vehicles. The crankshaft receives rotational force from the piston during the combustion stroke only. It loses force in all other strokes, due to inertia loss and friction. The flywheel maintains the rotational force inertia during strokes, other than the combustion stroke, to cause the crankshaft to rotate continuously. It also helps smooth out the power surges, changes from the engine. Intake manifold. The primary function of the intake manifold is to evenly distribute the combustion mixture to each intake port in the cylinder head. Even distribution is important to optimize the efficiency and performance of the engine. It also serves as a mount for the carburetor, throttle body, fuel injectors and other components of the engine. Exhaust manifold. Exhaust manifold collects exhaust gases from all cylinders and guides them to the exhaust pipe. The exhaust manifold is bolted to the cylinder head, opposite the exhaust port of the intake manifold. Exhaust manifold is generally made of cast iron or stainless steel. This brings us to the end of this topic.